let's start recording the lecture. So we talked last class about shear force and bending moment diagram. And if I would want to give you one single summary of why are we doing this, it's because when we have a situation like this, let's just have a quick discussion on this. These beams that you see are subjected to a concentrated load and a concentrated moment. First, يا أخوان, الكلمة beam, the word beam, technically has an implication. It's not a joke. You can't just call something a beam, while it is not a beam. A beam is a very precise definition. What is it? Anybody knows what a beam is?
Regarding the structure of it, I think it's not a rod. The cross section is not circular. It's either I or squared.
طيب, anybody else?
ممكن البيم يكون ديزاين I.
Okay. Anyone else?
The beams probably supports other structures and buildings and such things.
Okay.
Beams have supporter.
Maybe we assume it's unbendable.
Okay, that's a close. That's a little bit close.
For the beam, one piece only. One long piece. No joint in the middle or like this. Not two pieces, not three.
Okay. So what's a pipe then?
A pipe is hollow.
And if I make the pipe not hollow, is it a beam?
It's a rod.
Why?
البيم اللي هو الريزستر لود اللي الابلايد على شو اسمه الاكسل.
Okay. Well, welcome to the machine design, baby designers. You think you are still too young for design, يا شباب. Go ahead, يا أحمد.
Maybe it's regarding the shape of the cross section.
No. No. Look, we are designers, right? We don't necessarily care about how things look like. Our job, ya shabab, is to design for stress and strain. Yes, you may ask me a question. Why are we only talking about stress? In this course, everything is going to be about stress, not strain. There are many reasons why, okay? But forget about the fact that we are only talking about stress, not strain. Forget about it. Since we are stress designers, we should only care about stresses. And the way we distinguish different shapes, is not because they look different. It's because they are designed to carry different stresses in different ways. So, for example, beam is designed in a way to handle bending loading, to handle bending stress. Now, you might put a beam, يعني مثلا يا أخوان الآي beam اللي تكلمتوا عنه, the famous I-beam. Nobody would disagree that if you go to IKEA, for example, or like most people in Saudi Arabia call it IKEA, which is not true, but anyway. The idea is that the I-beam that are used to construct IKEA structure, the ceiling structure, are used as columns. The same I-beam is used as column. The technical, scientific, engineering design, stress-based definition of that structure هو عمود, column. The columns are scientifically designed to carry compressive loading. No tension, just compression. عشان كذا الستراكشر نفسه البادي حق الستراكشر السكند فلور الثيرد فلور فيفث فلور all of it is pushing against the column. الكولوم وظيفته واحدة, كأنه شخص واقف وحاط يديه فوق راسه كذا وقاعد يحمل اللود فقط. No bending, no tension. If you take the same geometry, same I-beam, and you orient it, so the I-beam, if you let it stand vertically like this, and you apply a compressive load on it, this is called a column. But if you take the I-beam like this, and you support it from here, you support it from here, and then you apply a load which is transferred to it, it's going to cause it to bend. Bending is totally different stress. So beams are structures that are designed to take bending load. Now, it is very nice about I-beam that their capacity to handle bending is really, really good. And there is an explanation for that. We are going to talk about it. Otherwise, يا أخوان, أنا بقول لكم حاجة يعني, why shouldn't we make this, solid, more material, stronger? That's what people used to believe. And then try to bend it. So what you see here are beams, two beams. Why? بس تشوف العمود عليه perpendicular load. ها؟ ما يهم. يعني مثلا إذا كان العمود واقف كذا حطيت عليه load, ما دام deformation is bending يا أخوان, then this is a beam. عشان كذا you need to develop your senses. What are the forces? What are the reactions? What's going on inside? And when you say what's going on inside, you should describe it by F. You should describe it as we discussed last time. F, V, M, T. That's number one. Number two, the best way to understand what is in your hand is to visualize what happened to it. So, logically, if you look at this beam, anyone who has a little sense of what forces do, is that you say, okay, this is going to bend like this. Very simple. And this guy on the bottom will bend like this, and then the moment might cause it to go like that. Something in that sort. So whenever you see the deformation causing curvature, curvature in the structure, this is beam. For that reason, we are studying now beams. Now, this is why, ya akhwan, in the previous lectures, we talked about bending moment and shear force in beams. Now, why beams? Why not talk about column in compression? Why not? We will talk about them. Why not we talk about rod? We will talk about them. But beams are very important because they are subjected to bending, and bending is very dangerous. You will see later. Now, what I want you to do right now is to spare 5 minutes of your time, take a pen, a pencil, a piece of paper, and try to draw the free body diagram for this. That's number one. Then when you draw the free body diagram, try to determine the reactions. And after determining the reaction, see if you can go to plotting the shear force diagram, maybe bending moment diagram. That's too fast in 5 minutes, but let's see how far you can go. I'm gonna stop the recording. I'm gonna be quiet. You take 5 minutes. It's 10:15 right now. In 10:20, we are gonna come back. Okay, take your time. Okay, Akhwan, we're coming back. So let's go and do this together, all right? So what do we have? If you still can see, I don't know the slide. I have to take that off, but let me try to make this proper as much as I can, okay? Is it? It didn't work? Sorry.
Yes, yes, sir.
Okay. So this is the drawing for the first beam. And now we are going to draw the second one. I'll see how lucky I can get. No. Okay. Now, if you look, we will have for the first one a reaction RA, and then a reaction RB, and then we have a 10 kilo-pound of force. This is 2 feet, and the distance here is 3 feet. Okay. Over here, we have a reaction RC, and we have over there a reaction of RD. Now, right here, that reaction RB will be reflected over here in a different direction. So RB will be applied this way. In here, we have a moment of 4 kilo-pound feet, okay? And the dimensions are, maybe I should make them in red, just 2 feet, 3 feet, and there is another 2 feet. Good, ya akhwan. Now, what are we gonna do? We are going to start with, just 1 second. Okay, now let's go. For AB, okay, so beam AB, we'll take upward as positive. We will sum up the forces along Y, and we say that this is equals to 0, which give us RA plus RB is equal to 10. Correct?
Yes.
Yes.
Okay, good. If you have any question, please stop me. Then we will sum up the moment at point A. Okay, I don't care a lot about the direction, honestly. Is it clockwise, positive, or why? Because I'm gonna put all of the clockwise in one side, all of the counterclockwise on the other side. So I don't need to have any negative or positive. That's why in the slide, I don't even care about that. Similarly, the forces, I don't care which one is positive, because I will take all the one upward in one side, all the one downward in another side. You get my point? That's the reason. So what are we gonna do? We'll have RB multiplied by 5, which is equal to 10 multiplied by 3. Do you see that?
Yes.
RB, just for those who may not see this, RB is gonna cause a moment like this. And it has to be multiplied by this distance, 5, which is 2 and 3. But the 10 kilo-pound is in the opposite direction, and it is that force multiplied by 3. Very simple. Now, if we solve these together, we will get RB equal to 6 kilopound and RA equals to 4 kilopound. Yes. Anyone? Okay. Now, let's move on to the next beam. For beam, let me maybe try to make it with green. I don't know if it's going to be nice or not, but for, can you see it? For
Yes.
CD, okay? The beam CD. Now, we will have the sum of the forces along Y equals to 0, which will give me RC plus RD equals to 6. Correct? Or
Yes.
not?
Yeah.
From where did
Yes.
I get the 6, ya shabab?
The reflection.
From the first beam.
Yes, from RB. I determined RB. بعد ليش أخليها يا شباب unknown? Why? Now, and then I will take the moment about point D, and I will say, or no, I actually have the solution with the moment about point C. So let me stick to my solution. Okay, about point C, which is equals to 0. And therefore, I will have RD multiplied by 7. Is that correct? Do you see the 7, ya shabab?
Yes.
Yes, yes.
This is RD. This distance is 7. It is 2 plus 3 plus 2. Now, which is plus 4.
4.
What is 4?
المومنت بنفس الدايركشن.
Yes, that moment. Do you see that moment, يا أخوان? هذه ما لها distance. It's not a force. It's an applied moment. هي جاهزة. هي عبارة عن force by distance multiplied together. So I don't need to multiply it by anything. It's just the moment. And now this is equal to what? 6 multiplied by 2. So from these two equations, I will get RD equal to 1.14 kilopound and RC equals to 4.86 kilopound. Good, ya akhwan?
Yes.
Okay, now let's move on to the next one. So what do we want to do? We will draw the shear force bending moment diagram for the first beam, which is beam AB. Is it, what did it ask for? Oh, it was asking to draw the shear force and bending moment diagram for CD only. So I don't need to draw it for this one. Do you see? So the question is only to do this. Now, what should I do? I do the following. This one, I should put the reactions, which are 4.86 kilopound, and then I have 6 kilopound, and then I have a 4 kilopound feet, and then I have over here 1.14 kilopound. What are the distances? This is 2 feet, this is 3 feet, and this is 2 feet again. Good?
Yes.
All right, now what I am gonna do, I am going to draw very thin line with the green just to make sure that I have the point where changes in forces or in moment are taking place. Good? So, and then with, let's say I am gonna use the black color should change the intensity again to this. This is going to be X in feet. And this one is what? V in kilo pound. Good? Down in there, I'm running out of space, but I will try my best to squeeze it. This is X in feet, and this is what? M in kilo pound feet. Now, let's use the yellow for the shear force diagram. شو قلنا احنا يا شباب؟ نبدأ بالرياكشن. صح؟
صح.
Okay. So, what is the reaction? 4.86. So, this is 4.86. This one is 4.86. Constant. Nothing happened. And then, all of a sudden, I go -6. Correct?
Yes.
أيوه.
So, when I go -6, I will reach to exactly minus 1.14. And this minus 1.14 راح تمشي إلى النهاية وبعدين توصل إلى 0. لاحظوا يا أخوان. The fact that there is a moment right here does not change anything in the shear force diagram. It's a different animal. This one, this diagram, only look at forces, arrows, vertical. Anything that is rotating like a moment torque doesn't show up here. He doesn't feel it. هذا تسأل يقول لك زي الثرمومتر، يقول لك الثرمومتر هذا كم درجة الحرارة؟ درجة الحرارة 38 36. أنت عندك فيروس، عندك مرض، عندك جرح، ما the thermometer cannot measure it. It can only measure your temperature. Okay. Now let's move on to the moment. The moment is the area under the shear force diagram. So just to tell you that this is our area over here. Now in red, let's draw the shear force diagram. راح نبدأ بصفر وراح ننتهي بصفر. No doubt about it. Now, all what we need to do is to look. Since this area is constant, ليش؟ rectangle. وهذه أيضاً constant، معناها ببساطة الشير فورس البندنج مومنت diagram راح يكون عبارة عن خطوط منحنية. خطوط. الاريا راح تكون like this. That's it. It is not like this. Why? لأنه هذه second order.
First.
Yeah. What we have is first order. It's an integration of a constant. So, as we said before, this area is 4.86 multiplied by the distance 2. لما تضربه يطلع كم؟ 9.71. You draw a line. Good يا أخوان?
Yes.
Okay. Then look carefully over here. اللي صاير الآن إن إحنا نحتاج نعرف هنا ما في force، هنا في bending moment, applied moment. So إحنا نعرف إنه المومنت هذه مقدارها 4. صحيح الكلام. بس في المقابل عندي أنا منطقة هنا، شايفين هذه المنطقة؟ هذه راح تضيف أو تنقص من هذه. فإيش أسوي؟ أجي أقول خليني أحسب الاريا هذه. هذه الاريا كم؟ 3 مضروبة في minus 1.14. فكم يطلع المقدار؟
3.42
minus
minus.
3.
Yes.
بالماينس.
صح ولا لا؟
ايوه بالماينس.
Okay. So what will happen is the following يا شباب. ان احنا حنجي ونقول شوفوا كذا، شوفوا الطريقه، راح نجي نقول هذا M1 بنسميه. اوكي، هنا راح نصل الى نقطه اسمها M2 زي ما علمتكم امس. M2 will be equal to M1 plus what? Minus 1.14 multiplied by 3. Now M1 is how much? 9.71. And then we need to subtract 1.14 multiplied by 3. The result will be 6.29. So أنا حاجي هنا. Yes. Okay. So أجي هنا وأحط هذه M2 اللي هي عبارة عن 6.29. طيب الآن لاحظوا يا شباب، لو طالعوا الفورس هذه اللي سببت المومنت هذه if you look at the beam as if this one is causing a moment with respect to this distance which is a clockwise، صح؟ فإحنا هنا هذه المومنت في الحقيقة هذا المقدار من المومنت is a clockwise moment. Okay? And then we subtracted a little bit of it. It went from 9.7 to 6.29, but it is still clockwise. بعدين ايش سوينا؟ في نفس اللاين on the same line I have another point here which is M3. Now M3 will be equal to M2 minus 4. ليه؟ لأنه هذه clockwise هذه clockwise هذه اللي هي 4 كيلو pound is counterclockwise. So I'm gonna subtract 4 from it. And what are you gonna end up with? I'm gonna end up with a value here which is equal to 2.29. So the diagram will go down vertically. هذا هو أثر المومنت اللي تكون applied at one point. إنه it will cause a vertical drop. ما يحتاج إنك تمشي على الديستنس عشان تقلل المومنت. طيب خلاص الآن عندنا انتهينا. صار أنا عندي مومنت M4 اللي هي هذه M4 هي عبارة عن 2.29 صح؟ بلس المقدار هذا كم يا أخوان؟ هذا هو عبارة عن minus 1.14 multiplied by 2.
which is 2.28.
Which is
almost
2.28
zero.
some. Almost zero. So it will go to zero.
دكتور
Yes.
ليش كان vertical drop ما هو vertical rise؟ الحين كيف عرفت انه المومنت اللي قبله counter clockwise؟ ما عرفت افرق كيف عرفت؟
Okay. Very simple. انت look at the bending moment diagram. هو كأنك انت قاعد تعمل كات. فانا لو جيت ورسمت البيم اوكي هنا الرياكشن صح ولا لا؟ اول فورس هي 6 كيلو باوند بدون ما تعقد نفسك. انا لو قلت لك الان سؤال، لو قلت لك هذه الفورس لو اخذت المومنت about this point هذه المومنت راح تكون عباره عن rotation in a clockwise fashion صح ولا لا؟ خلاص فالبدايه هذه سببت rotation clockwise. فخلاص انا تجمعت عندي المقدار الاول هذا وبديت انقص منه. ممكن في لحظه من اللحظات البندنج مومنت دياجرام يصل الى انه هو ينقلب يصير بالاسفل، فيصير عندك مقدار من المومنت بالنيجاتيف وبعدين يبدا يزيد مره ثانيه ويرجع الى الصفر. ما في مشكله. It's okay.
فالريفرنس حقي يكون اول فور
Yes.
بعد
Yes.
الرياح.
Yes. Okay.
دكتور
All right. Yes.
ما أدري but we have studied في CE إنه إذا كان المومنت counter clockwise it will make a drop automatically يعني وإذا كان clockwise it will make a rise. هل هذا الكلام ينطبق دائما؟
شوف هذا ساين كونفنشن. ابقاكم يا شباب تتحرروا من الموضوع هذا عشان ما يسبب لكم ازمه. اتس ساين كونفنشن. انت احنا نتفق انه الكاونتر كلوك وايز والكلوك وايز واحد منهم نيجاتيف واحد منهم بوزيتيف صح؟
صح.
خلاص احنا بدينا هنا يعني جرت العاده يا اخوان ان احنا نقول يعني conceptually انه if you have a shear force causing a shear force الاريا هذه تعتبر positive area معناها انه in the bending moment diagram you will have an increase value in the moment. واذا كان الجزء negative هنا it will cause a decrease in the value. فانت لو تلاحظ انه هذا المقدار البوزيتيف جاي من rotation which is if you think of it as a force multiplied by distance is a clockwise rotation. Make it like this, you will be fine. You will end up subtracting them. And by the way, I have to tell you one thing. There are situations where a negative sign or positive sign will cause a problem when you add stresses and subtract them. But in general, if you are consistent, it doesn't matter. Do you understand?
Yes.
Okay. Now, what I want to show you over here is another example which we are not going to solve together because we have only 8 minutes left and we should talk about stress, which is very important. Just to be on the schedule. This example has a little trick, which is the hinge over here. Also, it has a distributed load. So, just to show you that the location where the hinge is here. الهنج يا شباب allows rotation. If you allow rotation, there is no reaction moment. If there is no reaction moment, its value is 0. And this is just to tell you that point. The other thing is, since this is linear here, you got a second order. So this example is solved almost in the same way as we did. Look, same methodology. But it will teach you what happened if you have a second order equation. So this is good for revision. You will do it by yourself. For now, in the remaining time, we are going to talk about stress. Okay? In precisely, we are going to talk about normal stress. Okay? Because there are other stresses. Now, as a definition, the stress, ya shabab, is a measure of the internal forces acting within a deformable body. Very precise, clear definition. The fact that the body is deformable, because if it is not deformable, okay, then there is no, the stresses are minor or even 0. And it's a rigid body. So this is a deformable body. And it's the stress is a measure of the internal forces. So you can always think of it. That's why most of the time, whenever we draw a cross-section and we apply a force on the cross-section, we represent the force by one single arrow. But the truth is that we tend to represent the stress by many, many, many arrows. Why? Because what will happen is the following يا شباب. أول حاجة لازم تعرفوها بأنه stress ما نقدر نمثله بone arrow. If we do it, it's because we get tired. يعني على سبيل المثال احنا متعودين بأن احنا نرسم element like this and we put the stress like this. In principle, that's okay. But in reality, it should be like this. Always. ليه؟ One big problem انك انت تعتقد بأن stress is a vector. It is not. If you are geek in mathematics, then you should know that stress is a tensor. Tensor. It is called tensor. Tensor يا أخوان are higher dimensional vectors. We cannot represent stress by 3-component X, Y, and Z. في الحقيقة أن stress is more crazy than this. Stress is defined in 6-dimension place, and our mind cannot digest what does 6-dimension mean. We barely live in 3 dimensions, and maybe time is 4th with respect to physics. But you tell me we have a 5th dimension or a 6th dimension, what does that mean? However, stress is a tensor. It can be represented by a 3-by-3 matrix. That's a stress. Now, are we going to teach you this? No, you should be happy. If you are really into the stresses, you should take graduate courses like continuum mechanics and so on. They will give you a lot of these nice things. But what does this mean to you, أنت? إنه stress, if it is not a vector and it is a tensor, what does that mean for us? It means إنه هو field. Do you understand? It's a field. Now, what does field mean? الفيلد يا أخوان معناه إنه stress is like this. If I ask you this conceptual question وقلت لكم ما هو ارتفاع الأرض? What is the altitude of Earth? Can anybody answer to me?
With respect to what?
Reference to what?
Yeah, that's what you are going to say. Mathematically, Earth is a field. How? لأنه إحنا صحيح نرسم الأرض as a sphere. But in reality, if you look at Earth, if you zoom into Earth, Earth has mountains. This is Mount Everest, probably. Kilimanjaro. Okay, and so on and so on. Now, if I ask you what is the altitude of the Earth, you will ask me where? Give me a set of coordinates on Earth, and then I will go to Google Maps and put the pointer there, and maybe I can get the height of it. And it is always measured with respect to the sea level. The sea level is here. And although I didn't draw it, but if you measure this distance, you will measure it with respect to this level. Now, stress is the same يا أخوان. Always remember that the stress is the same. إيش معنى الكلام؟ معنى الكلام إنه أنا لو أجي وآخذ beam, a rectangular beam, and I apply force on it, and then I apply bending on it, I know for a fact that the tension is going to cause a uniform stress distribution. But bending is going to cause a linear distribution, which, if you remember, it is like this. So, if I look at the cross-section from the side, it is easier. A normal stress is causing a stress like this, and the bending stress is causing a stress like this. Now, إذا كان عندك only the blue color, لو سألتك قلت لك what is the stress in the cross section? You will tell me it is 10 megapascal. And logically, if I look at the cross section, every single point in the cross section, if you ask it, you tell it, how much is the stress? It will tell you, I am 10 megapascal. The problem is this. When you look at the cross section from the eye of the bending stress, this value is 10, this value is 8, this value is 6, this value is 0. So, لما تيجي حق الكروس اكشن هنا وتحط في الاعتبار انه في ستريسز باللون الاحمر، تسال الكروس اكشن تقول له كم ستريس يا شيخ؟ والله ما ادري، ممكن 10، هنا فوق 10، تحت -10، في المنتصف 0. يعني لازم تحدد، تقول لي what do you want. That's fundamentally the meaning of the field. Now, I know that many of you now probably understood what a field means, but I don't think it is second to nature inside you. So please try to remember it, because you will always make mistake thinking that stress is a vector, is one point. It's not. للأسف, stress is not. It's always different. It can always be different. Okay, يا أخوان. Have a nice weekend. See you next class إن شاء الله. السلام عليكم.
عليكم السلام. شكرا.
Yes.
عليكم السلام.
Yes.
يعطيك العافيه دكتور. بالنسبه حق الليكشر نوتس هذه، مثلا المساله اللي حليتها رحت ترفعها في البلاك بورد ان شاء الله.
Yes. Yes. After the end. For now, the only way to get you engaged trying to solve by yourself is to hide the solutions from you. That's why I put the slide without the solution. After the end of the chapter, I will upload the slide with the solution.
تمام. يعطيك العافيه
دكتور